of this F R plus union 0 arrow marking R, what does it mean?
All real values except for 0. No.
Except for 0? Union doesn't mean except. Union means including
Oh,
this also, isn't it?
yeah.
So what is this?
So all real numbers including 0.
For what? What it will give you? If you include this 0,
Mm-hmm.
what it will give you? How it is
Um,
related to your function? I want to know how it is related to your function. What it want to tell you? So we have discussed, see, Liza, if we have written sometimes F A to B, what is the
mm-hmm.
meaning? So this F is written as name of your function. This is your name of function that we are going to tell you something about
Mm-hmm.
this function F. And this is your domain. This is written your domain, and this is written your codomain. Do you know what is the domain and codomain of a function?
Um, I don't know what a codomain is. No.
Okay, domain and codomain. So, domain, function is what? Function is a mapping from set 1 to set 2, right? So, from
Mm-hmm.
here to here, if you map according to a rule, so for example, I have 1, 2, 3, 4, and I may have write 1, 4, 9, 16, 25, right? And
Mm-hmm.
now I have mapped like this way. So
Okay.
the domain is your set X, the domain is your set X, 1, 2, 3, 4, and codomain will be your set Y. In the codomain, I
Okay.
have 1, 4, 9, 16, and 25. But if someone is asking what's the range? So in the range, you will have only those members which have been mapped from your set X. So in the range, only this one, but codomain may be bigger thing also. So we can
Yeah.
say the range is subset of codomain. The
Okay.
range may be smaller than codomain, but not greater than codomain. So are you getting what's the domain, what's the codomain? So in
Yeah.
this example, it wants to tell you that your domain is, what is this now? What is this R plus? What is the meaning of this R plus?
All real positive numbers.
Positive what? Positive integers, positive what? Positive real
Real
numbers.
numbers.
This R is real, so positive. So can you tell me positive real numbers starts from where?
From 1 onwards.
No, sir.
0
Positive real
onwards.
number, not zero. It will zero
From
plus.
1.
It means it will start from here like this. Just
Yeah.
not zero, but zero plus here, here, here. These all are positive, isn't it?
Okay.
So,
Yeah.
but it wants to tell you including. So, if you write only R plus, it means 0 onwards, except 0. 0 is not a positive, 0 is not a negative, but it wants to tell you from 0 to further. So that's why they have included this union. It means they want to
Mhm.
tell you, okay, I'm including this 0 separately. Are you getting?
Okay.
So now
Yeah.
your domain is this is 0, this is 1, this is minus 1. So now it wants to tell you that we are considering this section. It means including 0 onwards. Correct?
Mhm.
So this is your
Okay.
function f. And what's the rule is? So f of x is log e x plus 1. Correct? No
Mhm.
problem.
No.
The first question is saying find the f inverse of x. How we can find the f inverse of x?
Swap x and y.
Sorry?
Swap x and y to find the inverse function.
No, no, no. That's a direct way you have remembered, right? For example, this
Mhm.
is telling you that, okay, do in this way and this way. See, they have written directly this result. No. This is not the correct way. Sometimes it maybe give you the wrong answer. So how we can solve? Wait. So okay. Wait. I want to do you revise from this PDF from
Yeah.
this material?
Yeah.
Okay. Okay. So let me give you some extra concept of function. So I have created this separate list. You can revise it. See, Liza, if we have to find the inverse of any function, first of all, every function is not invertible. You should know
Mhm.
every function is not invertible. Every function is not invertible. So which function is invertible? So only one and on two functions are both conditions should be matched. Functions are invertible.
Okay.
Now method. We are interested in method only. I will explain the second one also, but due to lack of time, I'm ignoring this explanation. So I'm just
Yeah.
coming to the method directly. Now suppose, okay, so fx is equals to 2x plus 1, right, Nigel?
Mhm.
So as per
Yeah.
your concept, what should be f inverse of x? Can you tell me what should be the f inverse of x?
It should be 2y plus 1, or x is equal to 2y plus 1.
You want to say x is equals to 2y plus 1. Now,
Yeah.
what is the meaning of F inverse? So please verify, please feel it first. This is inbuilt part of your syllabus. I have seen your paper. Sometimes they ask inverse function also. Suppose I have one, two, three, and four, and
Mm-hmm.
this is the mapping. One will be mapped to 3, 2 will be mapped to 5, 3 will be mapped to 7, and 4 will be mapped to 9. Is it okay? See, this is your rule F. I have
Yeah.
this mapping as per this rule. You can verify. Am I right? So
Yeah.
this is your f of x. You have taken the input and you have done this processing. Now we are finding the f inverse. F inverse means from this side to this side I have to map now, right? So
Yeah.
this is called your F inverse of X. First of
Mm-hmm.
all, F inverse of X doesn't mean that it is 1 over Fx. It is wrong, right?
Mm-hmm.
It is wrong. It is entirely a new function you are getting, a new rule you are getting. But we can see f inverse x, we can say it is g of x, we can say this is h of x, but generally we say this f inverse x. Why? Because it gives us a extra information that okay, this is the reverse of that function. Otherwise,
Mm-hmm.
it is also a function. So you are
Yeah.
telling me that f inverse x should be equals to, you want to say f inverse x is equals to, in terms of x, you will say, in terms of x, you will say this as 2x plus 1, right?
Yeah.
You know this? So, okay. So you are telling this way that if I go in, see, I should get in this manner, I should get such a function, I should
Mm-hmm.
get such a rule in which if I put this 3, if I put this 3, you should get 1. Am I right? If I put this
Mm-hmm.
5, you should get 2. If you put this
Mm-hmm.
7, you should get 3. Am I right? So do
Yeah.
you think that this is working? See, 2y plus 1. Suppose I take y is equals to 3. Suppose. So will you get
Mm-hmm.
1? Are you getting one?
But don't you have to still just rearrange it so then you plug in those values to see if you can get one?
No, no, please repeat what you're saying. See, now we are doing in the reverse manner, right? From here to here.
Mm-hmm.
So now this will be your input. We are taking our reverse function from here, inverse function from this side to this side. So this
Mm-hmm.
set becomes your domain. Am I right?
Yeah.
So if you take any one of these inputs in this, you are telling this rule that you will get this x. So if I
Yeah.
take any y, suppose I'm taking this 3. If you put 3 here, so are you getting this x 7? This x should be
No.
1. If you put this 5, are you getting this 2? No, entirely no. So this is 110% wrong. Are you getting this?
Yeah.
So why? Yeah, tell me.
No, no. Yeah, I'm following.
Then why sometimes teachers say this directly that okay, just change x and y. See here also what they have done. I think they have just changed x and y. Can you see this? In
Yeah.
this first bit, they have changed. They have they have initially changed this x is equals to this and this, but if you go in this manner, you have to do something more. See here, your inverse function is this one as per this question. They have just initialized this method. Are you getting my
Mm-hmm.
point? They have this.
Yeah.
This is the just first step of this method. So, are you getting that? If you are taking this approach, what you have to do? So, if you take this approach, then again we have to do for y. It means if you have do this one, if you have done this one, please see the correct
Mm-hmm.
method. The correct method. This is not my method. I will give you another method, but let me continue this. So, first of all, you have exchanged your x and y, right? Then again find for y. Again find for y. Again make y as a subject. So what you will get? You will
Yeah,
get
that's what I
x
was
minus
saying.
1 by. You are saying this one?
Yeah, that's what I was saying before. I said, don't you have to first make, like, then you resolve it, so y is the subject?
Okay, okay, okay. Then it is correct. Otherwise, okay, just skip this. I have another method also. So
Mm-hmm.
you will get this one. Any problem? Then what's the
No.
problem? You can solve. And sketch the graph of f and f inverse x. So tell me, Nisa, is there any spatial property between the graph of f and f inverse?
Spatial property, meaning
Is there?
they'll both be on in the first quadrant.
No,
Not
no,
gonna go
no,
anywhere
no,
else.
no, 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 no.
What?
So any
What?
function and its inverse
Oh.
function, if you plot any function and f inverse function, if you plot any function f x and f inverse of x, they are symmetrical. They
Mm-hmm.
are symmetrical with respect to line y is equals to x. This is the important property. So you can visualize here. See, y is equals to x line will be this. So can you see that? Yes, they are symmetrical with respect to the
Yeah.
line y is equals to x. It is just like mirror image of a red curve with respect to y is equals to x line, or we can say mirror image of blue curve with respect to y is equals to x line. This is the extra
Yeah.
information you should know. You must know. Okay. Find the exact value of the area for this 0 to log e to f inverse of x. It means for the b bit, we have to solve 0 to log e to f inverse x. What is f inverse x? This is e raised to
Mm-hmm.
power x minus 1 dx. And I think you can integrate it. You know the
Yeah.
integration of e raised to power x. You know the integration of 1. You can just put the limit. Would you like to try this integration?
I know how to integrate it, but yeah, I don't know how to put the limit as log
Try
base e to
this.
the power two.
Try this. That's why I'm saying try this. Try this. limit substitution. Wait, this right. So this is the bay bit. We have to solve 0 to log e2. I have sent you this PDF, annotated PDF in the last class. I think no, not sent,
No.
right?
Yeah.
Okay, okay, I will send it to you. So it will be e raised to power x minus x. But I have sent you the
Yeah.
class recording. Have you seen that?
Yes.
Okay. So log e2. So how we
Mm-hmm.
will put the limit, Nisa? First of all, upper limit, then lower limit. So you will get,
Mm-hmm.
right, e raised to power log e2 minus log e2. This is the upper limit. This minus lower limit. So e raised to power 0 minus 0. Correct?
Yeah.
So what we will get? Can you tell me the value of this thing? Can you simplify this little bit? What is this?
Um, they both have.
Only this part, this red part. E raised to power log e and then 2.
Okay. Um,
Write this, write this. We have discussed many time. Many time in the last class also, I think we have discussed when we have proved a raised to power x is equals to e raised to power x ln a. If you have remembered, we have discussed a raised to power
mhm.
x is equals to e raised to power x ln a. Have you remembered this? Yeah, see here. And I give you this result. Okay, no problem. Let me write. So please see, Naisa, make a separate notebook for all these formulas now. There are so many properties which are going on. So this is, if you
Yeah.
have e raised to power log e a, please see, this is nothing but your a. We have proved it also. We can prove it right now. But you have to remember
Yeah.
this. E
Yeah.
here base should be E and here this should be E. Then you will get this A direct. You should write it.
Yeah.
Okay. So as per this, we are getting 2 minus log E2 this minus. What will be E raised to power 0, Nigel? What will be
One.
E? 1. Very nice. So this will be 1. So now we can simplify this. So 2 minus 1 is 1. So it will
One.
be 1 minus log E2. See, we are getting this 1 minus log
Yeah.
E2.
Okay.
Okay. The next bit it is saying find the exact value of 0 to 1 f of x. 0 to 1 f of x. So the C bit we are solving 0 to 1 f of x. What is my f of x? 0 to 1 f of x is log e x plus 1. Log e x plus 1. Can we integrate this?
Mm-hmm.
So we have not discussed the integration of log. I think this is the technology based. Okay. No. See, Nisa, this is very important. This is very important. This is very conceptual. What's the first problem we are getting here? What's the first problem we are getting here is, see, Nisa, we do not know integration of ln ex,
Yeah.
right? This is a major problem. We know the integration of 1 by x. We know. What is it? This is
Log.
ln ex plus c. But we don't know the integration of ln ex. Are you getting? This is the major problem, isn't it?
Yeah.
I can give you this result also, but that will a separate topic that is called integration by parts. Right. So
Mm-hmm.
your question is not saying to apply that method because integration by parts we have not discussed. What is
Yeah.
the integration by parts? Integration by parts is, you should know at least this name. Integration by parts means if we have two functions in multiplication, right? If we
Mhm.
have two functions in multiplication to integrate, then how we handle this? This is covered in your integration by parts. So here we can integrate with the help of two functions, one times ln ex. See, this is the product of two function I am considering. The first one is the algebraic function, and the second one is the logarithmic function. Right? This is
Mhm.
called integration by parts. You can remember this. It is integration of ln x is x ln x mm, x ln x minus uh, so it will be, let me write, then you can
Yeah.
remember this ln ex and ln this continuous minus integration of by x. It will be x ln x, yes, x ln x minus x. So you can remember this one. Just this is I'm giving you for your emergency situation. Are you getting
Mhm.
this, Raisa? This
Yeah.
is I'm giving you for your emergency situation. Just remember this. I'm not discussing this integration by parts due to lack of time, but
Mhm.
you can remember this for your emergency time. Are you getting suppose this type of question has been come and you are unable to think, then you can apply your this powerful formula. What is the
Yeah.
this integration of ln ex is x ln x minus x. Is it okay?
Yeah.
But right now, your question is saying to think in this different manner. Your integration by parts is not in your syllabus. So we
Mhm.
how we can integrate this? So for that, see this now. We will use the symmetric property of this log x, your fx, and this f inverse x. So we have to
Mhm.
find 0 to 1. See here, now this in this graph. Now see the graphical approach. This is the f of x, right, Nisa?
Mhm.
We have to integrate 0 to 1. So this is 0 and this is
Yeah.
1. For 1, what we are getting? We are getting log e2, right?
Okay.
So,
Yep.
yeah. And we have this inverse function of
Mhm.
this is this one, and it means suppose for 1, for x equals to 1, suppose if I plot x equals to 1 here, this is the x equals to 1. So for this, we are getting something here, and similarly for f inverse x, you will get something here. So we
Mhm.
are interested in this area only, right?
Yeah.
So what they have done, seen as a
Mhm.
either see the concept. We are interested in this one, right?
Mhm.
We are interested in this reason R2, but we are unable to integrate this function. That's a limitation,
Mhm.
that's a problem we are getting. So what they have done, they have calculated the area on y-axis. Now see, how we find the area on y-axis? Area on y-axis. Have you remembered how to find the area on y-axis? We have discussed. First of all, give an integration sign, and now you will put the limit dy here. Am I right?
Yep.
And since you have written this dy, you should have the limit for y here and here. And now you have to put here f of y. Have you remembered this? F of y we have put it
Yeah.
here. So what is the f of y? So see, initially your f of x was, this is your y is equals to f of x. We write it generally log e
Mhm.
x plus 1. So now I have to find f of y. How you will get f of y? You have to write x is equals to f of y. This is nothing but your inverse function. See, you have written the reverse thing. Y is equals to
Yeah.
this. Now, what is the f of y? So, f of y we have already calculated. See, it is e raised to power y minus 1. Are you getting this, Nisa? See? We
Yeah.
have this. So it means for the same function, if you are just written, if you are just writing this integration for area on y-axis, if we
Mm-hmm.
are willing to write area on y-axis, so we can find it now easily because
Mm-hmm.
exponential integration is known to
Mm-hmm.
us. So what should be this R1? I want to write the reason R1. So it
Mm-hmm.
should be integration. Where to where? See, your knife will start from right. So it will go
Mm-hmm.
from y is equals to 0 to y is equals to log e2. Am I right? Let me just see.
Yeah.
And f of y is e raised to power y minus 1 times dy. So you will get this R1. Can you integrate this? This is a very simple integration. E raised to
Mm-hmm.
power, and I think we have already integrated this. See, this is the
Yeah.
same thing we have done. That's it. So this is 1 minus log E2. So we are getting this as 1 minus, so this is 1 minus log E2. Correct?
Mm-hmm.
So,
Yep.
and we have the total area of this square. If you see this is the length 1 and this is the width. So the
Mm-hmm.
total area is 1 into log E2, isn't it?
Yep.
Of the rectangle, total area of the rectangle, we can say. So the interested reason that is R2 will be the total reason that is the log E2 minus 1 minus log E2, isn't it? So
Mm-hmm.
if you solve it, you will get this log E2 minus 1 plus log E2. So overall, we are getting 2 log E2 minus 1. Are you
Yep.
getting this, Nizer?
Yeah. I am.
Any doubt?
No. Yep. And because the thing is, I just tried also in the CAS in the calculator just to make sure because I'll be allowed a calculator to see if I actually have to do all of it. And yeah, I got the exact same answer. That's
Very
good.
nice, very
Okay.
nice. Area between the two curves, we have